So as I mentioned, 5.3 is just kind of putting a bow on 5.1, 5.2, and talking about perfectly competitive markets, specifically perfectly competitive factor markets, because 5.4 focuses on imperfect and monopsonies. But we said that, one of the things that firms always try to do is maximize their profit. And back in units 3 and units 4, we talked about the idea that firms would maximize their profit where MR equals MC. Like you should already have that, absolutely hammered into your head by this point. What we're going to see is that when it comes to factor markets, firms maximize their profit where MRP equals MRC, right? Like remember, MRP is the additional revenue and marginal resource cost is the additional cost. Now, the one difference between these two when it comes to like what's the difference between these and like marginal regular old marginal revenue or regular old marginal cost? Well, if you notice in our equation there, the marginal revenue product is the change in total revenue over the change in the quantity, but it's the quantity of our labor, not the quantity of the product. So when we found marginal revenue, just regular old marginal revenue, it was the change in our total revenue divided by the change in the quantity of the product. But this is the change in the quantity of the labor, since labor is a resource and these are resource markets or factor markets. Same thing with the resource cost. Marginal cost, just regular old marginal cost, was the change in total cost that divided by the change in the quantity of the product. But once again, since this is talking about resource or factor markets, it's the change in the quantity of the resource. So that's the big difference here, but they'll still maximize their profit where MRP equals MRC. Why is that? Well, remember, if MRP is greater than MRC, so right there, we're at our quantity of 4, anything over there to the left of that quantity of 4, if you notice our MRP, which is the blue line, is greater than our MRC, the red line, like it's higher than it. And because of that, every time we hire another worker, it brings in more revenue than it costs to hire them, which is adding to our profit. I'll show you guys that actually on the next slide. But once we get past that point, if our MRP is less than our MRC, so any point there to the right, you see the red line sits higher than the blue line, it's costing us more to hire a worker than the revenue they bring in. And so we wouldn't want to go there. We'd start to lose profit. It's where they are equal that we maximize it. This isn't necessarily in your notes. I just kind of put this together because I wanted to illustrate this idea for you a little bit more, and hopefully this will make a little bit more sense of it. Like, let's go through worker by worker to see how this works for us, like how this helps us earn like the maximum amount of profit. So let's look at worker number 1. So if you went straight up from quantity of labor at 1, you would see we bump into our blue line, our demand curve at 400, meaning that first worker brings in an additional $400 of revenue. But our marginal cost for them, our marginal resource cost, is only $250 because it costs us $250 to hire them. That means we are adding $150 in profit to us because, right, they're helping us earn $400 more of revenue. We only pay them an additional $250. The change in profit there is $150, so our total profit is $150 now. When we get to that second worker, remember, because of diminishing returns, the MRP for that second one is a little bit lower, right? It's only $350. Like if you went straight up from the quantity of 2, you'd bump into our demand curve at $350. But still, we're only paying this one $250. So off that worker, we earn an additional, right, $100. If you add that additional $100 in profit to that first $150, you'd have $250. Then we can do that same thing for worker number 3, right? Worker number 3, if you go straight up, they bring in an additional $300 in revenue. It costs us $250 to hire them. Hey, we're making $50 in additional profit from that worker. Add that 50 to the running total of 250. That's 300. Now, once we get to number 4, if you notice, MRP and MRC are equal, right? And we end up seeing that change in profit is 0. But this is what I want you to notice is that like our profit is not increasing, it's not decreasing. And so it stays at 300. But what happens after that? Like once we go to number 5, like MRP for number 5, well, because of diminishing returns, if you notice, if you go up from number 5, we bump into our demand curve at $200, but it costs us $250 to hire them. That means we're actually losing $50 on that worker, which means by losing that $50, our total profit drops from 300 down to 250. And same thing if we went on to like number 6, right? Our MRP is 150, our MRC is 250. We would actually lose $100 on that worker. We pay them 250, but they only bring us in an additional 150. So that means our total profit would fall even further. So where do we maximize our profit? Well, we maximize it at 4 workers. And some of you might look at this and you say, well, why not 3? Because they're both 300. And I hear what you're saying. But we're assuming here, like we're talking about very like discrete values here. Like imagine that we could hire workers for portions of days, right? So we could hire a worker for, we could hire 3.5 workers. And by half worker, we mean, hey, one of you workers come in for half a day. We could still be adding more to that profit. And it's like, where do we squeeze out the total amount of profit? And it would be there at 4. And so, yeah, it's where they end up being equal. That's where we're going to end up maximizing our profit. And the last thing that we have here is profit maximizing behaviors. This actually ties back into multiple other topics that we've talked about. One of which was, let's see, whenever we talked about like maximizing utility with a budget constraint, this is actually the same sort of idea. Remember, we're trying to decide like, hey, should I buy more of this or more of this, and what's the marginal utility per dollar that I'm getting? But what we're actually going to end up seeing here is that we're going to talk about the same thing, but instead of it being like utility maximization, we're going to look at it as cost minimization. Why? Because now we're on the spending end as the producer, right? And we're trying to decide, hey, what's the best combination of, let's say I can hire workers to do a job, or I can hire capital, meaning like have a machine do it instead, right? What are my options? And so what we're going to do is we're going to look at marginal product per dollar in the same way that we looked at marginal utility per dollar. Here, our benefit is product. Why? Because whenever we hire workers or, bring in machines, our goal is for those workers or machines to make us stuff, right? And we're able to sell that stuff. So we're looking at the marginal product. And we're looking at it per dollar because, maybe to hire a worker or to hire, a machine capital, it's going to cost us different amounts. And so what you'll end up seeing is something like we have down here is MP over PL, right? For, what's the marginal product divided by the price of labor. What that means is every single time I hire an additional worker, they're going to bring me in additional units of product. But how much money am I essentially spending on each one of those units of product when I hire that additional worker? Or again, for capital, right? Every single time I bring in another machine, I got to pay money for that. What is the additional number of units I get per dollar from that machine? And so let's suppose that we're trying to decide and we're saying, hey, we need to figure out what's the appropriate number of workers and machines to hire in order to produce our good. Well, how do we decide? Well, we would use our cost minimization rule. It's called like the least cost combination. And what we're trying to do is get the marginal product of labor divided by the price of labor equal to the marginal product of capital divided by the price of capital. And this should look so familiar to us. Why? Because it's literally the exact same thing that we looked at with utility maximization, where we had like marginal utility of A over the price of A equals the marginal utility of B divided by the price of B. Like the same concept. And so what we're going to find is a firm will find its least cost combination where the additional product per dollar spent on labor is equal to the additional product per dollar spent on capital. So what does this look like? Well, first of all, what we need to do is we need to work through these tables. And I'm not necessarily going to ask you guys to do this. Let's kind of just work through it together. So let's look at labor. Let's calculate marginal product. Obviously, we got nothing for no workers. But when we hire that first worker, our quantity or our total product goes from 0 to 160. So that's 160. From 160 up to 300, that's 140. 300 up to 420 is another 120. And then an additional 100. 520 up to 600 is 80. 600 up to 660 is 60 more, and then 40 more. So that's our marginal product. Every time we hire another worker, how much additional units of the product do we get? And we see it decreasing because of the idea of diminishing returns. Too many cooks in the kitchen, like we talked about. Let's do the same thing for our capital, right? Every time we bring in another machine to do the work. Whenever we hire that first machine, bring that first machine in, let's say that machine can produce 500 units of product. And then that next one, let's say, brings in an additional 450, right? From 500 up to 950. Then 950 up to 1350 is 400. 350, 1700 up to 2000 is 300. Then 240, and then let's say 180. And you might look at this at face value and be like, yeah, capital is like way more productive than labor. Like why would we even worry about hiring workers? We're getting so much out of our capital. Well, yeah, that's true. But also remember, you're paying 2.5 times the amount for every machine you hire than every worker you hire. And so that's why we have to look at it at a per dollar basis. So as we go through, what we can do is let's calculate the marginal product per dollar, because we want to see kind of like what's the most bang for our buck. Like that's the way we're looking at it here. So when we hire that first worker helps us bring an additional 160 units in, but we got to pay them $40. So if we do 160 units divided by the $40, that it costs to hire that worker. What that means is each dollar we're spending on that worker is essentially bringing us in an additional 4 units of the product, right? 160 products, we paid $40 for it. So that's four products, 4 units per dollar. Then 140 divided by 40 is going to be 3.5. 120 divided by 40 is 3. 100 divided by 40 is 2.5. Then 2, 1.5, and 1. So that's the additional units we get per dollar spent every time we're like hiring another worker. Now let's do the same thing for capital. So obviously we got nothing there when we got nothing, but whenever we hire that first unit of capital, the marginal product, the additional product is 500. But again, we spent $100 to get those 500. So 500 divided by 100 is 5. Then 450 divided by 100 is 4.5. 400 divided by 100 is 4. And then 3.5, 3. 2.4, and then 1.8. So let's say we're given a situation where it's like, hey, suppose a firm has $620. That's like their budget to spend per day on either labor or capital. Well, what would be the best combination? Well, similar to our previous situation where we said, first of all, we need the least cost or those marginal products per dollar, or as we talked about before, marginal utility per dollar to be equal, but we also have to stay within our budget. And so what we would see is here at hiring 3 workers and at 3 units of capital, 5 units of capital, each of them have a marginal product per dollar of 3. And also, if we're hiring 5 machines at $100 a piece, that's $500, plus 3 workers at $40 a piece, that's $120. 500 plus 120 is our $620. And you might be like, well, again, why that point? Well, keep in mind, if those aren't equal, like let's say we were hiring one worker. Let's say we hired one worker. We're getting marginal product per dollar of 4, while we hired, 6 machines, and that's 2.4. It's like, well, why would I be hiring that 6th machine? I'm spending $100 and it's only getting me 2.4 units per dollar, whenever my first worker was getting me 4 units per dollar. Like I should be hiring more workers because they are more productive at that point than the machines are. And so we would start hiring more workers, which means we're bringing in fewer machines, and we wait till those balance out. And once they equal, we know that we are not better off using our money toward more labor or more capital. Like when they are equal, that is our cost minimization, meaning we're getting like the most bang for our buck.